Q. How are tsunamis caused and highlight the areas which are prone to tsunami. Discuss the working of tsunami early warning system. 250 words. Key demand of the question. The question has 3 parts which need answering. First of all, we need to explain what causes tsunamis, the areas where tsunamis are more likely based on the geographical features which cause tsunami. Finally, we need to discuss the different kinds of tsunami early warning systems and their working. Directive work. Discuss. In your discussion, the explanation to the various parts asked in the question is to be written. Structure of the answer. Introduction. Explain what tsunamis are. Body. Discuss how tsunamis are caused. Examine what physical features are more likely to cause tsunami and mention the areas of the world where the likelihood of tsunami is more. The areas most prone to tsunamis are coastal areas that are near earthquake-prone regions or near areas of undersea volcanoes and face the open ocean. Thus, the coast of Japan, Southeast Asia and coastal parts of Southeast India and the Andaman and Nicobar Islands are prone to tsunamis. Also Ring of Fire in the Pacific. Finally, mention the different kinds of tsunami early warning systems such as buoys floating in the ocean, through remote sensing satellites. Explain it as well. Tsunami. Tsunami is a series of large waves generated by an abrupt movement on the ocean floor that can result from an earthquake, an underwater landslide, a volcanic eruption or, very rarely, a large meteorite strike. However, powerful undersea earthquakes are responsible for most tsunamis. Seismologists say only earthquakes measuring greater than 7.0 on the Richter scale can produce a major tsunami. Most earthquakes that generate tsunamis occur in areas called subduction zones, where pieces of the Earth's crust press against each other. The friction between two slow-moving plates of the Earth's crust creates vast amounts of seismic energy which is released in the form of an earthquake. www.insightsindia.com 45 www.insightsays.com. Secure synopsis. When a strong undersea earthquake strikes a relatively short distance below the seafloor, it abruptly pushes up one of the immense plates of the Earth's crust. That suddenly displaces an enormous amount of ocean water which becomes a tsunami, spreading outward in every direction from the epicenter of an earthquake, like ripples on a pond, only on a much larger scale. Tsunamis generated in the open ocean appear to be only small waves, but they can grow rapidly in size as they reach shallow water before crashing into seacoast settlements. Areas that are prone to tsunami damage is usually worst in areas closest to the undersea quake, often because the fast-moving waves will hit land so quickly. The areas most prone to tsunamis are coastal areas that are near earthquake-prone regions or near areas of undersea volcanoes and face the open ocean. Thus, the coast of Japan, Southeast Asia and coastal parts of Southeast India and the Andaman and Nicobar Islands are prone to tsunamis. Also Ring of Fire in the Pacific. Tsunami early warning system. It is made up of 2 equally important components. A network of sensors to detect tsunami, the communications infrastructure to issue timely alarms to permit evacuation of the coastal areas. It is made up of a network of seismic monitoring stations and sea level gauges. These detect earthquakes and abnormal changes in sea level and help scientists decide whether a tsunami has been triggered by an earthquake. When operating, seismic alerts are used to instigate the watches and warnings. Then, data from observed sea level height, either shore-based tide gauges or dark buoys, are used to verify the existence of a tsunami. Other systems have been proposed to augment the warning procedures. For example, it has been suggested that the duration and frequency content of T-wave energy, which is earthquake energy trapped in the ocean so far channel, is indicative of an earthquake's tsunami potential. At present, early warning systems rely on measuring the movement of dark buoys which record changes in the sea level or assessing the bottom pressure of the propagating tsunami. The problem is that these systems require the tsunami to physically reach the measurement location. With the speed at which tsunami waves travel through open water, no system can protect against a very sudden tsunami, where the coast in question is too close to the epicenter. www.insightsindia.com 46 www.insightsays.com. Secure synopsis. Q. Discuss the concept of air mass and explain its role in macroclimatic changes. 250 words. Key demand of the question. The question expects us to answer by explaining what air masses are, essential conditions for the formation of an air mass, and how an air mass differ from a mass of air. Finally, explain how air masses impact the microclimate of a region. Structure of the answer. Introduction. Explain that an air mass is a large body of air having uniform temperature, humidity and pressure which it adapts from the surface present below it. Discuss the essential conditions for formation of an air mass such as uniformity in meteorological conditions, sample time and plane topography which plays an assisting role. Body. Explain how air masses impact the microclimate. Creation of an occluded front. Maritime air masses causing rainfall, cyclonic and anticyclonic conditions, etc. Give examples for these impacts on microclimate. Air mass. An air mass is a large volume of air in the atmosphere that is mostly uniform in temperature and moisture. Air masses can extend thousands of kilometers across the surface of the Earth and can reach from ground level to the stratosphere -16 kilometers into the atmosphere. Air masses form over large surfaces with uniform temperatures and humidity. Called source region, they acquire a distinct identity by their humidity, origin and movement. They are classified based on latitudinal origination, Arctic, tropical, equatorial, Antarctic, etc. Continental air mass / oceanic air mass. An air mass may sit over its source region for long periods of time, or it may migrate. An air mass on the move begins to transform as it passes over new landscapes, while at the same time retaining enough of its original conditions to alter local weather. www.insightsindia.com 47 www.insightsindia.com. Secure synopsis. Conditions for the formation of air masses. Source region should be extensive with gentle, divergent air circulation slightly at high pressure. Areas with high pressure but little pressure difference or pressure gradient are ideal source regions. There are no major source regions in the mid-latitudes as these regions are dominated by cyclonic and other disturbances rolled in macroclimatic changes. Most of the migratory atmospheric disturbances such as cyclones and storms originate at the contact zone between different air masses, and the weather associated with these disturbances is determined by characteristics of the air masses involved. Low winds let air remain stationary long enough to take on the features of the source region, such as heat or cold. When winds move air masses, they carry their weather conditions, heat or cold, dry or moist, from the source region to a new region. When the air mass reaches a new region, it might clash with another air mass that has a different temperature and humidity. This can create a severe storm. The properties of an air mass which influence the accompanying weather are vertical distribution, temperature indicating its stability, and coldness or warmness, and the moisture content. The air masses carry atmospheric moisture from oceans to continents and cause precipitation over land masses. Frontal precipitation. When warm air mass and cold air mass come in contact, frontal precipitation occurs. It is widely witnessed in temperate region. The air masses, when pass through warm water or currents, acquire their moisture and cause rainfall in coastal regions. The climates of most regions worldwide are affected by air masses. For example, maritime tropical air sourced over warm waters of the Atlantic Ocean, Caribbean Sea and Gulf of Mexico, primarily between 10 and 30 degrees north of latitude, is the main contributor of precipitation for much of North America east of the Rocky Mountains. They transport latent heat, thus removing the latitudinal heat balance. Desertification. They cause arid conditions when dry air mass is present in a region. Sahel region of Africa is impacted by this. Cyclonic and anticyclone conditions. When these continental air masses move towards pole side and polar air masses move towards equatorial side, both of them form fronts. These cyclonic fronts are responsible for cyclonic storms at temperate regions. Stormy cyclones form near the air mass fronts. The temperate cyclones occur in the mid-latitude of both the hemisphere. These cyclones are born along the polar front, particularly in the region of Icelandic and Aleutian subpolar low pressure areas in the northern hemisphere. A continental polar air mass originating from the tundra of northern Canada may push southward during the winter. It brings frigid temperatures to the central United States, even as it warms up somewhat on its journey across lower latitudes. While dry in its source region, such an air mass often picks up substantial moisture during an early winter transit of the Great Lakes, allowing it to dump so-called lake effect snow on leeward coasts. Also helps in creation of an occluded front. www.insightsanindia.com 48 www.insightsains.com Secure synopsis. Topic: changes in critical geographical features including water bodies and ice caps and in flora and fauna and the effects of such changes. Q. Discuss the various theories of formation of Earth. Examine how Juno mission will keep us understand the formation of Earth. 250 words NCERT Class 11 Physical Geography page 14 Reference key demand of the question. The question expects us to explain the various theories of formation of Earth and examine how would the Juno mission help us in understanding the formation of Earth. Directive word examine. When you are asked to examine, you have to probe deeper into the topic, get into details, and find out the causes or implications if any. Structure of the answer. Discuss the different theories like the early theory, nuclear hypothesis, Vicant binary theory, revised nebular hypothesis, Big Bang theory. Explain the purpose of Juno mission and discuss how it would be useful in understanding about formation of Earth. Various theories of formation of Earth. Nebular hypothesis. Immanuel Kant, the German philosopher, gave this theory in 1796. The mathematician Pierre Simon Laplace re-examined it. The solar nebular hypothesis describes the formation of our solar system from a nebula cloud made from a collection of dust and gas. It is believed that the sun, planets, moons, and asteroids were formed around the same time, around 4.5 billion years ago, from a nebula. The hypothesis considered that the planets were formed out of a cloud of material associated with a youthful sun, which was slowly rotating. As gravity condensed the gas, rotation of the gas increased, spreading the gas cloud into a rotating disk that would form the plane of the solar system as we know it today. Evidence of this can be seen because all of the planets revolved around the sun in the same plane and direction. Binary theories. As per these theories, the sun had a companion. In 1900, Chamberlain and Moulton considered that a wandering star approached the sun. As a result, the cigar-shaped extension of material was separated from the solar surface. As the passing star moved away, the material separated from the solar surface continued to revolve around the sun and it slowly condensed into planets. Sir James Jeans and later Sir Harold Jeffrey supported this argument. At a later date, the arguments considered of a companion to the sun to have been coexisting. These arguments are called binary theories. Revised nebular hypothesis. Revised nebular hypothesis was propounded by Karl Wieseckart in Germany and Otto Schmidt in Russia. They regarded that a solar nebula surrounded the sun and that the nebula comprised of chiefly hydrogen, helium and something called dust. The collision of particles and the friction caused a disk-shaped cloud to be formed, and then the planets were created via the accretion process. Big Bang theory, alternatively called the expanding universe hypothesis. Secure synopsis. As per this theory, in the beginning, all matter or substance forming this universe existed at one place as a tiny ball. This tiny ball had an extremely small volume, infinite density and temperature. At the Big Bang, this ball blasted fiercely and forcefully and started a substantial process of expansion which continues to this day. Now it is accepted that this event took place 13.7 billion years ago. Juno mission. Juno will improve our understanding of the solar system's beginnings by revealing the origin and evolution of Jupiter. Juno will determine how much water is in Jupiter's atmosphere, which helps determine which planet formation theory is correct or if new theories are needed. Look deep into Jupiter's atmosphere to measure composition, temperature, cloud motions, and other properties. Map Jupiter's magnetic and gravity fields, revealing the planet's deep structure. Explore and study Jupiter's magnetosphere near the planet's poles, providing new insights about how the planet's enormous magnetic force field affects its atmosphere. How Juno mission helps in understanding the formation of Earth. Juno will let us take a giant step forward in our understanding of how giant planets form and a role these titans played in putting together the rest of the solar system. With a diameter of 140,000 kilometers and a mass of 318 Earth, Jupiter dominates our solar system. In fact, its gravitational influence is so enormous that it affects the orbits of all the planets. It is thought that the planets of the solar system originally formed in a slightly different configuration, but Jupiter's huge mass upset the gravitational balance, causing it and Saturn to migrate inwards, while Neptune was flung further out in the solar system. And that's why Juno's mission is so important, as it is impossible to understand how our planetary system forms without knowing more about this colossus. Jupiter took most of the mass that blew away from Sun. It has twice the combined material of the other bodies in the solar system. Studying their composition holds key to unlocking the heavy elements which are no longer in Earth's system but were originally present. Unlike Earth, the solar winds couldn't blow away Jupiter's hydrogen and helium because of the distance. So, Jupiter's atmosphere ought to have evolved from a mechanism other than degassing. This mechanism needs to be studied to refine our own ideas of how Earth's atmosphere was born, and Juno mission can scientists regarding this aspect. Due to extreme atmospheric pressure, Jupiter's hydrogen turns liquid and forms large oceans. Studying this will help to know how our atmospheric gases behaved during origin of Earth. Jupiter's gravitational influence is said to be so enormous that it affects orbits of all planets. Juno mission's gravitational readings will refine our understanding of Earth's annual journey around the Sun. Jupiter has strongest aurora emissions in the entire solar system. Juno mission helps scientists to study them to deepen their understanding of Earth's own northern and southern lights. The effect of Jupiter's gravity and magnetism on its moons and vice versa. Studying these interrelations will enhance our understanding of Earth-Moon relationship. We may even arrive at a mathematical formula to shortlist the planets in the entire galaxy where we can find life forms. Conclusion: in our solar system, planet Jupiter has the largest surface, biggest ocean, strongest gravity, strongest magnetism. This giant holds answers to aforementioned key questions regarding our own atmosphere, its gaseous composition, magnetism, orbital path, and relationship with the Moon. www.insightsindia.com 50 www.insightsays.com. Secure synopsis. Indeed, Juno mission's Jupiter data will thus help refining and enhancing our understanding about the origin and evolution of